talk about our last new thing in the year 2022.
Hey.
Okay, so today and tomorrow we're going to focus on what's called dilation. So we're going to take some notes today. We're going to practice it more tomorrow. So we might take like a few notes tomorrow. So it's not like our last lesson. Okay, but this is our last new material. Okay. So we're going back and you can kind of see how your notes look very similar to what they did back when we did rotations, reflections, translations. Why didn't we learn dilations back then? Okay. Well, when we talked about rotations, reflections, and translations, we always had congruent figures. But a dilation, has anyone got their eyes dilated before?
I don't know what that is.
Okay, Bennett, what do they do? And then what happens to your eyes? Okay, well, your eyes get blurry, but
They get big.
okay, your pupils stretch out. Okay, so a dilation, they call that dilate your eyes because it stretches out your pupils. Okay, a dilation is a stretch or a shrink of a figure. Okay, so we had to talk about similar figures before we could talk about dilations. Okay, because we are taking our shape and we are making it bigger or making it smaller. That's what I mean by stretch or shrink. I feel like sometimes the heater just smells like random food.
It always smells like chicken Alfredo.
I know. Okay, so then how do we know how much bigger or smaller to make our figure? We are going to have what's called a scale factor. Okay, and the scale factor is going to tell us how much to stretch or how much to shrink our polygon. Okay, now we will always use the letter K. K is going to be the letter that we use for our scale factor. So you'll kind of see down in the practice problems that you see like, okay, here's some coordinates and then K equals 2 or K equals 4. That's our scale factor. That's what we're going to use. Okay. And we've talked about scale factors before when we talked about something. When we talked about similar figures last week, I threw out the word scale factor a couple times. Okay. Now, we need to figure out when the dilation is going to be a stretch, or I guess they call it an enlargement. Okay. Or a shrink. Any thoughts on what K is going to be? You just like look at the problems on your page and look at the different K values. Let's just kind of see if we can guess. I see a couple problems. K is 2, K is 4, K is 1/2, K is 1/3. What do you think? What's going to make it get bigger? What's going to make it get smaller? Okay, good. Okay, so I also want to throw the word out here, reduction. Put reduction by shrink. So you know, like reduce means to get smaller. All right. I'm going to say stretch and shrink, but really the real words are enlargement and reduction. Okay. So Bennett, you're right. When our scale factor is bigger than 1, our picture is going to get larger. When our scale factor is smaller than 1, then our figure is going to get smaller. It's going to shrink. It's going to reduce. The reason why we're just now talking about this is because dilations result in similar figures. Okay. They're going to be the same shape, but they are not going to be the same size. They're going to be proportional, and the scale factor is what gives us that proportion. Okay. So this is what's going to happen. We need to plot our points. So let's go here to number 1. And we're going to plot A, B, and C. So this is like, oh my gosh, how many times have we plotted points now in this class? A is at -3, 4. So let's just remember it's been a few days. Ryan, help me get to -3, 4. Which way do I move 3?
To the left.
And then 4. So left 3, up 4. There's my A. Okay. 2, 1. Arisa, and how do I get to +2, +1? Great. Right 2, up 1. And then C is -1, -5. Braylea, how do we get there? Great. Okay. So make sure your picture looks like mine. Any thoughts on what we're going to do with K equals 2? So we're not going to move right or up or anything like that. This is our scale factor. What? Oh, let's talk about that. If it's K equals 2, is it going to shrink or is it going to grow? Okay, so this is an enlargement. Okay, or a stretch. Okay. So what we're going to do, we're going to multiply everything. By 2. Every single coordinate, X coordinate, Y coordinate, we're going to multiply by our scale factor. Okay. So if A is at -3, 4, and I multiply both X and Y by 2, -3 times 2 is, and 4 times 2 is 8. So our new coordinate is at -6, 8. Coordinate B, we are literally going to take the coordinate 2, 1, and we are going to multiply the X and the Y by 2. So what's 2 times 2? 4. And what's 1 times 2? So our new B coordinate is at 4, 2. Okay. And then last but not least, -5, -1 is C. So if we take -5, and we multiply both X and Y by 2, Tyler, what's our new coordinate going to be for C if I multiply both of those by 2? So -2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How beautiful that is. Okay. Do you see how these figures would be considered similar figures? The two triangles have the same angles, just one is bigger than the other. Exactly how much bigger is the red triangle than the green? Twice as big. Okay. Since our scale factor is 2, our new triangle is twice as big as the original one. Okay. All right, so let's go ahead and number 2, let's go ahead and graph these points together. Okay. So, ooh, they're all in the first quadrant. That is so nice of them to do. 2, 3. We're gonna go 2, 3 to point P. 4, 3 for Q. 3, 1 for R, and 1, 1 for S. So this is just a cute little parallelogram. I sure hope that we have an enlargement and not a reduction. What do you think? All right, so Bennett, do we have a stretch or a shrink? Okay. Corin, how does he know that it's going to be a stretch? By 4, and 4 is bigger than. So look up here. When K is bigger than 1, we know that it's going to be an enlargement versus if K is smaller than 1. Okay. So what I'd like you to do is I'd like you and your elbow partner to don't plot them yet, because let's check them first. I want you to come up with our 4 new coordinates. Okay. Did you get a haircut? Not much of one.
Dude,
Oh,
are you
my hair
judging?
wasn't like, I don't know.
But it's still.
Like if my hair wasn't like that, it would be like probably down here.
Really?
No, actually, I pulled it
What'd you
down.
say?
It was like right here.
Never mind.
You
No,
sure?
it's 'cause of
Mhm.
like this.
I actually understand this.
Okay, good. All right, let's check our coordinates. Trent, what do you have for P prime? 8, 12. Okay. Finley, what do you have for Q prime? 16, 12. Let's see. Quinlan, what do you have for R prime? 12, 4. And Ariana, what do you have for S prime? Okay, does anybody have any disagreements with these coordinates? No. All right, let's plot them. This is what takes the longest, plotting all these darn points. All right, I'm gonna start with 4, 4. We have some patterns here where a couple of them have the same Y coordinate as each other. So that can help you kind of figure out where to go, right? Okay. So waiting on a couple points to be plotted.
Turn in that reflections worksheet.
Okay, yeah, I need to just kind of like redo that whole board. You wanna go erase your name for me though? Okay, so let's go ahead and look at number 3. Number 3 is a little bit different. You'll notice that our K value is 1/2 this time. So before we even start plotting points, what does it mean when K is 1/2? Our figure is going to be smaller. We're going to have a reduction. Our figure is going to shrink. Okay. So our original figure is probably going to be pretty big so that we can shrink it. Okay. So let's talk about plotting these points. 8, -8. All of these are going to be in the 4th quadrant. So let's go to the right 8 and then down 8. So right now we're just working on plotting these 4 points. We're going right and then down for all of these. I'm kind of using like, if I know that this is at 16, I need to go 2 over for 18. This is probably the more tedious one because we are going to have coordinates that are pretty far from the origin when we're multiplying or dividing by numbers, okay, to get our new coordinates. So we'll just exercise some patience here. Okay, does your square look like mine? And I really like that in these problems, it tells you what the shape is gonna be. So if it says square EFGH and yours does not look like a square, then maybe we should go back and look at our coordinates, okay? Now I know that maybe you don't draw super straight lines, but we'll do our best, right?
What?
Okay, while we're waiting for a couple people to finish their coordinates, I want you to think of something you're looking forward to this weekend. I know it's only Wednesday, but we can still be excited. Okay,
For a weekend, a weekend.
well, in a couple days. Okay,
Wait, hold up. How many days do we go to school next week?
5.
Oh, I thought we only had 3.
Yeah, Jada, you need to fix your countdown. Well, now after today, it's gonna be 7.
After today, it's gonna be 7, right?
Yep.
Yeah.
That feels like forever.
It's going by quick. We're already to Wednesday. Okay, so now what's gonna happen since we have this K equals 1/2? All of our coordinates get multiplied by 1/2.
I didn't even do that.
Okay, what's another way of saying multiply by 1/2?
So 8 is 4.
What'd you say, Arisa? Oh, multiplying by 1/2 means the same thing as dividing by 2. So 8 negative 8 is going to become 4 negative 4 because we're dividing by 2. Okay. 16 negative 6 is going to become 8 negative 3 because we're dividing by 2. $18 negative 14. 9 what? 9 negative 7 because we're dividing both numbers by 2. And then 10 negative 16 is going to become 5 negative 8. Okay, so our scale factor is 1/2, which means that red square is half the size of the green square. Or the green square, how does it compare to the red? We can say that the green is twice as big as the red square. If the red square is half the size, then the green square compared to the red is double in size. Does that make sense? Okay. Okay. We could say that the red square is 1/2 the size of the green square because we multiplied by 1/2. Okay. All right, here's your homework. Go ahead and turn to page 25. 20 what? 25. Page 25. You're gonna do 1, 2, 3, 4.
Oh, is this filling up?
Oh, yeah, it is.
So do we do the whole
Yeah,
page?
Tyler.
So for
No.
today, I just want 1, 2, 3, 4.
That is great.